Previously talked about some of these drippers that for drip irrigation, and they work pretty well. I have some tubing just to show you. These push in here. This goes out to a water source. Come on, focus. There we go. This goes out to a water source. Oh, sorry, this side gets plugged into a water source, and this side drips on your plants. Now, like I said, the old one was a little small. It just can come out pretty easily, and I finally have some new ones that actually work. These work perfectly. So I printed out a couple, and these just push on just like the stock ones. They're the same diameter, here. They have a barb, mostly is right, and then this can push in just fine, and it'll stay on. Obviously, I'll push them in all the way. Don't want these to get stuck. Normally, if they're a little tight, you'll warm this a little bit, and then this will slide right in, and when it cools, it'll just be nice and tight. So, it took a bunch of iteration to get here, but these work beautifully. In order, of course, to get here, I had to print and print and print and print a whole bunch of times. The first one took about an hour. First design took about an hour to print. I got it down to 15 minutes or so for one of these, a little bit more than 30 minutes for two, the extra moves and stuff. And I ended up simplifying the design a lot. I spoke about how the previous design, I had a layer that was here, a layer that was down below, there was something joining them, there was a chamber here, water would come in, go down here, would go around, and then finally something similar where it would come out here. Or rather, it would come out. So I had moved it a few times in order to find the best approach, but then I would have a chamber here, and the outlet would be here. So the water would flow here, 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 around this whole thing, so it would look something like this from the top. It would have a flow, right, so the water would come in here, go all the way around, go here, which would be here, come down, go around this thing, and eventually come out right at this side. Something in here would come out. Instead, I used a similar idea, but what I found is there was too much resistance. So we just get a faint trickle coming out the other side. The stock drippers, the standard drippers, these actually have a small stream that would come out. So the design now looks very similar, except I've, like I said, simplified it quite a bit. So this comes down. I still have to have this chamber, and then it goes to the resistive element, and now I only have one. And then I have a tube coming out. In this case, it's just a block, but that's just to make it easier to print. Printing around things when the bed's this way sometimes can be a bit challenging. So for the test, I figured I'd just save the time, just to see how that does. From the top view, it looks very much the same. We just have one chamber, so I'll draw it this way. Let's square the whole way around. The size of this is about 1 millimeter. So it's 1 millimeter square, which is the resistive element here, this grid bit. And then this disc is above. Every layer is spaced by 1 millimeter. So there's, in the stack up, there's 1 millimeter here, 1 millimeter here, 1 millimeter here, and there's 1 millimeter above the surface of this element here, which is acts like the condenser or just a virtual water capacitor. Same story here. Without this, what you actually get is you just out of the side you would have a hole, and you would just get a jet, right? Because it would just be too fast. It wouldn't have a chance. So what we actually wanted is at the side, I just have basically a box right now, and with a hole in it. So what that does is, since this hole is larger than the inlet, which I'll just draw like that, the inlet hole is quite a bit smaller This is 1mm square. This is on the order of, I think it's 2 or 3 millimeters. So this side is always able to drain what this side's producing because it's larger. And this gives it a chance to take the stream. So the stream comes out of the grid array at some velocity straight, and now it hits this and just kind of pools, and it'll come out. Now, this has been working really great. It's still just printed in PLA, which doesn't always have the best performance outside, but I'm hoping that since water is generally flowing through these, and they're going to be at the ground, they're not going to get so much direct sunlight. We'll see how it performs. I'm going to print out a bunch, and then we can install them in the garden and see how they do overall. Something else worth of note is when you blow on these, so you gotta try forcing air in it, these you actually can feel that you're getting somewhere. With the first one, where they had the 2 layers, there was so much resistance even that you don't produce enough pressure with your lungs to be able to push through there. And that was really apparent. I've tried a couple of variations on the nozzle output. So on one, I just had it straight. So I just had a straight nozzle. And the other one, I actually tried flaring it out a little bit to see what would happen. It doesn't seem to make a difference. At that point, I was just trying to prevent the water from sticking to the sides here and dripping instead of flowing, water tension and all that. But it seems to be working pretty well. And once I have them all printed, I'll do a further update and we'll see how it performs over time with the drip irrigation and if the sun really messes it up. If it does, I'll have to try either PETG or some of the other materials that are available. I don't have the ability to print ABS right now. I don't have enclosure or anything like that to manage the temperature, but it's a good start and we'll see how it does, how it performs. I think it'll be okay, to be honest. It's one of the reasons I printed these in white instead of black. You know, it doesn't show up great as great on the camera, but it should help it with heat, which is the enemy of the PLA and any plastic or anything in general. So that's our 3D printed emitter. Once I clean this up a little bit, I will be posting the STLs for these, and I'll have a Thingiverse link down in the description if you want to try it out and let me know how it goes. See if it works for you, if there's any modifications you would suggest that might improve these emitters and make them perform a little bit better, be easier to use, or improve their printability, anything like that. I'm still learning modeling, so any help, super appreciated.